Hello, students. This is a brief overview of particulate diagrams. A lot of individuals believe that what makes chemistry challenging is we are asked to understand and try to explain things that happen that we can't see with our own eyes, that are happening on the atomic scale, on the microscopic level. So we use particulate diagrams to try to model what we as a group believe is the correct visual that we should have in our head of that atomic level behavior. So as you can see on the screen on the left, we use spheres, single spheres, if we're trying to represent a single element. Now we can have different elements in the same particulate diagram. They will be different sized spheres or different colored. Compounds are spheres touching. That means those elements are chemically bonded. So we can see in the middle particulate diagram that we have a compound that's made from two different elements. One is shaded a lighter blue and one a ivy green, if you will. Then to the right, that would be a different compound than is shown in the middle, because we have a mustard colored center element, and then we have the same three darker blue spheres, meaning the same element bonded to that center. All right, so those are definitely elements and compounds, but we know we can have mixtures. And so on the left, there's element with compound, and then on the right, compound with compound. Now, if you are being asked to judge homogeneous or heterogeneous, so on page 19 in your unit packet, there is a column showing, okay, these would all be classified as gases. We can see the particles are as far apart as we would definitely predict, at least 10 diameters apart. And we could say, oh, these are two elements because we've shaded in not. This is gaseous state of the same compound because we have spheres touching. Here is element and compound. Here are two different compounds. Now, liquid, I would honestly put these a little closer together, but in perspective, these are definitely closer. Those, so this is showing this substance if it was in the liquid state. So definitely closer together. We don't see any organization. These are much closer, well, closer, not much, but closer. And we see there's organization, there's rows. So compound, gaseous, then liquid, then solid state. Now, if we would come here. Okay, so we have element and compound, gaseous state, element and compound, liquid state, element and compound, solid state. Now, I think it's very, very hard to judge. I think the better call would be that this is a heterogeneous mixture. Now, if I divide this in half, okay, do I have the same number of darker spheres? That's my element. It looks like they're kind of centralized here. Where here, they're kind of spread out, They're not equally distributed. So I would definitely say heterogeneous. Now look at that. Isn't that much more of an equal distribution? I would definitely call this homogeneous. On page 18, there's some really, really good diagrams as well. So could we go through and identify which are showing solid, which are showing liquid, which are showing gas? We have touching, closely packed, and there's some organization. Solid. These are a little separated. I would definitely call this liquid. I'm sorry if that was off the screen. And then grand separation, gas. This is a compound, two different elements, same element as the solid. Heterogeneous, we can see layers. Oh, element with compound. I say this is homogeneous gaseous state, where this element and compound heterogeneous. So that gives us a little experience with particulate diagrams for Unit 1.